Thanks for joining. Session right before lunchtime, I think. No, there's one after me. Yes, so please don't panic. This session is about, well, API gateways in a way, modern next generation gateways. I think yesterday and today you probably heard quite a few sessions about AI. AI is everywhere in software development, obviously, but also in many organizations. And I will hopefully tell you within the next 30 minutes, when you think about putting AI workloads and agentic workloads into production, and really into production on an enterprise level, that you kind of need some guardrails, you need some additional components to make that scalable, to make it secure, and to make it production ready in a way. So many organizations nowadays, they have two problems, okay? They have shortage of skilled labor, right? Many organizations, you know, the boomers, they go into their well-deserved retirement. Work gets more, skilled labor gets less. And obviously, many organizations need to be more productive. They want to be more productive. And the promise out there right now is if you do something with AI, something magic with agentic AI, you get better assistance systems, you get better process automation, more intelligent process automation. And I guess if you do it right, this is a valid promise, if you do it right. The problem I see in practice nowadays, I do a lot of consultancy, not that much programming anymore. Everyone's keen in all these organizations, and each domain and every department, they go off and build agents on their own, okay? No governance whatsoever. They use different stacks, they use different tools. And what you see on an enterprise level is that you have this, well, kind of shadow IT thing going on, a strange local platform being introduced somehow, critical backend system being exposed on, you know, MCP protocol to the internet because you want to connect N8N SaaS platforms to it, as an example. And that's not good, okay? So you have a cost issue, maybe cost spiraling out of control. Each agent has its own guardrails, hopefully. Sometimes not even those. What if there are errors? You don't have traces, you don't have good observability, especially in the AI world. You also have quite a bit of regulation, at least in the EU. So DORA, AI Act, BaFin, GDPR. That's obviously highly dependent on the domain and on the vertical you're in. Okay. So if you have a proliferation of unmanaged agents, this will definitely pose a significant security risk for companies, for your company or for your clients, okay? So we have to do something about that problem. And this is mainly what this talk will be about. How can we solve this problem? How can we make it more secure? How can we reduce and mitigate the risk? So I'm Leander. I'm managing director, CTO. I work for a company here in Munich, which is called Coaware. Our main expertise is building custom software for large enterprises, and most of the stuff I tell you today has already been proven in some of our projects. Okay, so this is not a theoretical lecture, it's kind of best practices from some of our projects. So, what are AI agents? So, AI agents are some piece of software. It's an autonomous software system. Okay, so that's the first difference to, let's say, traditional, let's say, microservice-based systems. That not only answers questions, but it pursues goals independently. It makes decisions and carries out certain actions in order to solve a complex task. Okay, so you give it the question. The AI agent identifies the user objectives, works out the best way to achieve it, uses tools independently. So tools is mainly interacting with the environment, calling backend system, accessing a database, calling other systems, calling other agents, things like that. And ideally only gets back to the user once the job is done. Okay, so it can be thought of a virtual employee, if you say so. Okay. The problem with this is that it's not deterministic. Okay, you've probably all found out this yourself. Kind of the same question, two different outcomes. Okay, so we have these systems behave differently in production. Summing up, 5 key characteristics. So the first thing is this autonomy bit, okay? So ideally, it operates largely without human intervention to achieve its objectives, and it decides for itself how to achieve that objective, okay? It has some form of perception, so it sees its environment. So that can be a file system, that can be surrounding systems, whatever. It can capture and analyze text and data streams, files and directories, and also sensory inputs, which is mainly interaction with the user. It can plan and reason, okay? It's capable of breaking down complex tasks into logical steps, set priorities, adapt the strategies if things go wrong. Tool use, kind of important, so it can actively interact with other software, with other systems. Using APIs, it can write and execute code, it can use web browsers, it can search databases, so anything you can imagine an agent can kind of call. Also, memory, short-term memory, so it does not forget about the current task, and also kind of important often is long-term memory, so it can learn from the experience, it can learn from past interactions with the user. So that's an AI agent, just to briefly sum things up. The fun bit is, from an operational perspective, an AI agent is not so different to anything we've built probably the last 10 years, right? It's probably some containerized workload, some containerized process. Yes, the internal of that works differently. Less code, you have prompts, you have flow control, maybe you have sub-agents, you have the use of Gen AI and LLMs and the memory logic, and you also have the tool calling part via MCP. It can interact with some memory. Well, what is memory? Maybe a key value store, maybe a database, okay? So some store, some state store, basically. It can interact with LLMs or small language models, maybe domain-specific models, maybe hosted on your Kubernetes cluster, maybe some public domain models. Doesn't really matter. It can interact with tool servers, and interacting with a tool server is basically just a call, an HTTP call, using some protocol named MCP. And that tool server then makes the integration logic required to then access your database or your backend system. And also an AI agent can call other AI agents. Here comes the A2A protocol, which is very popular and highly been adopted by many frameworks. And again, you have clear responsibilities. An agent should be domain specific, it should have a manageable size. And yes, this whole system is highly distributed. So my pitch is, from an operational perspective, well, if we've done our homework, let's say the last 5 years, 6 years, 7 years, we probably built some container platform for our clients or in-house. Well, why not use that container platform to also operate our agentic workloads? Why not? This is just a quick history lesson. I mean, they're all probably pretty relevant, right? But the really relevant part is the 2025, where A2A and MCP come into play. So these are those two new protocols that are now highly popular in this agentic AI world. So agent-to-agent protocol, that's A2A, and MCP for model context protocol. Funny enough, the root goes back quite a bit. You see here, there's XML RPC, so that's 98. There has been a more popular version back here in 2005 and 2010, that's JSON RPC, and A2A and MCP are basically just a specific implementation of a JSON RPC protocol. The good thing is all HTTP, so from a protocol level and from an inter-process communication level, things are not so different to what we did again with our microservices and our REST-based system, maybe some of the other systems. Now, if you haven't heard of MCP, so think of MCP as like your USB-C port for AI applications. It has two distinct layers. It has a data layer and a transport layer. Let's start at the bottom. So the transport layer comes in two flavors. The one is standard I/O transport, which is not so relevant for us today. The other one is streamable HTTP. So basically it's an HTTP post with optional server-sent events for streaming functionality. So that's on the transport layer, so we have to support that. And on the data layer, you have responsibilities like lifecycle management, you have dedicated server features your MCP server can offer. So that is basically what the client can consume. So this is the tools you want to call. You can expose resources, so more or less read-only versions of some data via MCP, and you can also provide prompt templates. On the other hand, the server can also force the client, or can send specific requests back to the client to request certain client actions. So basically the server can say, hey, dear client, dear AI application, please ask the user some question. And also there are some utility features. Really important part is that here, the dedicated connection. So it's kind of a stateful protocol. Okay, so that makes things for MCP a little different, and you need to think about this if you want to put it on your cluster, that you need some form of stickiness. This here is just, we could skip this in a bit, but what I see out there is there are many options currently to convert maybe some open API to MCP conversion. I don't want to go into that into too much detail, so you can either do it framework-based, configuration-based, or generator-based. The really important part is this here. System integration via MCP, well, presents a number of challenges that must be taken into account, okay? So this is done probably in 5 to 10 minutes. Take your existing REST API and put like an additional MCP layer onto it. But the real thing is, what about all these cross-cutting concerns we usually talk about? What about policy enforcement? Is the agent actually even allowed to call this specific tool of this MCP server for this functionality, right? An MCP server just offers like 20 tools, but a specific agent may only be allowed to call 2 of these 20. How does he authenticate? How does he authorize? How can he enforce policy? Is the agent actually allowed to see the data that is exposed by that MCP server? So all these tricky parts, these are usually, well, I don't want to say forgotten by these easy approaches here, but just a word of warning, okay? Use one of these things, but then the homework starts, then the real work starts. This here is the easy part. Just take one of those generators or one of those configuration-based approaches, wrap things, convert things, but then you're not done yet, okay? So you need to take these additional challenges into account. Next one here, A2A, just a brief primer. Also, it's a standardized communication. Again, it's JSON RPC over HTTP. It has certain capabilities. So, for example, each agent can describe its capabilities using something called an agent card. So it's a well-known URL. You can call that, or other agents can discover the capabilities of other agents within its surroundings without being hard-coded. Again, you have some flexible interaction possibilities. So you have synchronous request-response style, you got streaming, server-send events, and also some asynchronous push notifications. So where another agent can asynchronously push responses back to another agent. There's a possibility for some rich data exchange, so you can send text, you can send files, you can send structured JSON data. And the good thing about that protocol is that some enterprise readiness is already taken into account. So security, authentication, and auditability is already provided by that protocol, which is really good if you want to put agentic workloads into production. Now, I hope you can see, now you have A2A, you have agents, well, more or less with the possibility to randomly talk to each other, randomly discover each other, and you have agents who, if you don't do anything, can access potentially any backend system, right? Given the MCP endpoint, they can invoke any tool whatsoever. So we really need to properly manage all these APIs, all these calls, okay? So the MCP, the agents, the LLM APIs, the MCP IPAs, right from the start, and that's kind of essential, otherwise you will probably pretty quickly end up in this ominous big ball of AI API mud. Again, not something new, the only thing is new that here basically is AI and there's agent, right? I mean, this is a challenge we kind of had the last 15 years in distributed computing already. So shouldn't be something new, just the APIs are new, and you have a few more players. You have agents and LLMs and MCP APIs. Now, API gateways also shouldn't be something new, I guess. API gateway is an established pattern out there, is an established infrastructure component pattern out there. And from a software engineering perspective, it acts like a facade pattern for AI applications. Okay? And it's an essential design pattern for agentic architectures. So what I propose is conceptually, you kind of need to think about 3 different gateways. You have the agent gateway, so that's your ingress endpoint. That controls the access to AI agents, so that's ingress into your distributed system. And the tool gateway and the AI gateway are kind of egress gateways. So the tool gateway is kind of the safeguard you put in front of all your MCP servers to control access to all these tools, to all these resources and prompts. And for the AI gateway, in my opinion, you should also put these in front of all your LLM providers. Again, to control access to LLM backends and to do kind of different cross-cutting concerns, right? You always have this possibility. Either you implement it. You remember the times when we talked about circuit breakers and service meshes? It was a long time ago, right? Probably 5 years ago. Same problem, different solution. But either you implement it in your agents, and we all know humans make mistakes, things are forgotten. If you want to handle things properly, just offload the responsibility into some infrastructure component, be it an API gateway, be it a service mesh, or these specific pimped up AI-ready API gateways. So what do you want to do with them? Well, traffic management, easy. Standard API gateway stuff. Path-based, header-based, host-based routing. Maybe you want to do some path rewrite. So you have one single point of entry into your agentic system, and then the gateway decides which agent to route the request to. You want some operability features. Fancy stuff like A/B deployment, kernel release. Maybe you want to do some FinOps there already. Quality of service and resiliency. Yes, you need some. I mean, circuit breaking is not dead yet, right? If you want your agent to be resilient, when it calls an MCP server, you have to implement some circuit breaking logic, right? Otherwise, it gets stuck if the MCP server is not there. Maybe you want to implement some retry logic. Maybe you want to implement some failover logic, right? Failover for LLM call. Right? These backend systems sometimes are also not available or return strange errors. So maybe you want to fail over from OpenAI to some other model. Caching becomes really important, right? Rate limiting may be important. Security, definitely a thing in 2026. So authentication, authorization, access control, all these things like JSON Web Tokens, OpenID for authentication. You want to implement guardrails. You may want to establish policies for different calls. Is this agent allowed to call that agent? Is this agent called to allow that backend system or MCP server? You may want to do some protocol translation. So maybe A2A to OpenAI protocol, right? Not everyone speaks A2A out there at the moment, but there is a way you can translate standard OpenAI REST API to A2A. And there may be other fancy protocols that become more relevant in an agentic world. Maybe you have some voice API, right, for a telephone agent. Again, you may want to do some transformation, maybe some filtering, maybe some versioning, maybe some fan-out collect stuff. And last but not least, observability. Really important that you kind of monitor how your agentic workloads operate in production from a regulatory perspective and also from a quality assurance perspective. So you need this standard logging integration, you want proper monitoring, you want proper distributed tracing, which agent called which agent when and which tool server, what was the request, what was the response, payloads. So distributed tracing, I think, is really super imperative in an agentic world. So all of these things can be, well, you can either implement them manually in each and every agent, maybe not so wise, or you can offload these requirements to some infrastructure component called an API gateway, or nowadays an AI gateway. Now, I will just briefly talk about 3 categories, okay? And I will not give you a comparison, use this and not that, okay? That wouldn't be fair. You have to do the homework yourself for your specific use case. But if you plan to use one of these gateways, and there are many out there, then obviously you need some criteria for a comparison. And this is not complete, okay? There may be other comparison criteria relevant for your use case. But obviously you would always look, in my opinion, for an enterprise case, for production readiness, for something called maturity, okay? So maybe not use the gateway with version 001. Maybe that's not so wise. You want a good community, you want good community support, ideally no issues, or let's say not so many issues on GitHub. You want frequent releases in terms of security, obviously, in terms of maintainability and maturity. Then it's always the license question. Do you go the full open source, or do you say, well, I'm an enterprise, I can afford it, I'll go for the commercial version? Might be a thing, either you have the money or not. Again, you have to look for the supported features. Do you need traffic management or security or caching or guardrails or API key management, failover protocol translation? So this is something you have to decide for your use case you implement, which features are really relevant for me. In a Kubernetes world, obviously, you want the full DevOps friendliness. You want easy setup, easy operation, maybe fancy operator towards it, you know, proper nice Kubernetes integration, platform integration, custom CRDs, maybe some CI/CD and GitOps support, and obviously good documentation. Last but not almost least, performance. I mean, that's a thing, right? It's an additional components. It's an additional network hop you would introduce with API gateways and AI gateways. So what you want is definitely low overhead, you want high throughput, you want scalability and availability, okay? And really good solutions, they offer that. So low overhead, I don't know, smaller than 100 milliseconds, high throughput, and availability. So only having one of these gateways is kind of a single point of failure. Then the gateway is the single point of failure. So again, these components need to be highly available. And observability, so you want proper open telemetry support, I guess, nowadays, right? So if a component doesn't have proper open telemetry support, I would say, maybe I'm not going to use that one. So logging, monitoring, tracing integration, I think this is the way to go. This is state of the art. This is how we should do it. So option A, well, you probably have that in your organization already. It's like a proper big API management solution. Full-fledged, Kong, Tyke, MuleSoft, APG, you name them. Probably they make sense for enterprise use cases. Probably the customer or your organization already has a license of one of these, then why not use it? They're often quite expensive, but hey, they offer a lot of functionality. Some of these offer a stripped down open source version. Yes, that's true. The sad reality is they're so stripped down that the really relevant features are not included in the open source version. So I guess if you go that route, then just pay them and just get the full feature set. They usually offer additional features you might need, you might not need. Developer portals, API key management, maybe some payment options, maybe integration into some enterprise access management solutions, API catalogs. And it's usually this here, the 80% rule applies, right? So you buy that thing and you probably only need 80% out of the full feature set. But that's okay. Usually they're deployed and operated centrally for all agents and all applications within the application, within the organization. So the bigger the company, the more likely it is that they already have one of these here. Now option B, that's the software engineer's approach. I'm going to build my own gateway. Yes. So there are numerous frameworks out there, a lot in Python. I found a few in Rust, some in Go. So just look around. I will tell you, you will find a framework that will enable you to build your own AI gateway. Super sweet, okay? Maximum flexibility. So anything you can program is basically possible. So you can make it as small as you like or as complex as you like. But that's also the biggest downside. You have to develop it, you have to maintain it, and you have to operate it, okay? So that involves a lot of work and carries certain risks, obviously, like with every custom development. So I would be cautious with option B, even though that's technically possible. Now, the good thing is option C, obviously this is Container Days, the Cloud Native Summit, not Container Days. There are a lot of really good AI native and cloud native gateways out there. As I told you, API gateways themselves are not something new, okay? Traffic, everyone knows traffic, right? Everyone has heard the name Envoy, or maybe KrakenD, or AP6. So these are traditional API gateways, and obviously they realize that there is a new era now of APIs. So each one of these has some form of AI gateway now. So it's Traffic AI, Envoy AI, KrakenD AI, AI6, Bifrost, Portkey, K Gateway, Highgrace, Agent Gateway, etc., etc. The good thing about these, nice Kubernetes support, nice platform support, all the goodness you would expect from such a component. They're all open source with additional enterprise offerings. Now they want to earn money as well. So for proper usage, basically you have to go for the enterprise offering, I would say, because you need all these usually would need all these enterprise features. They're lightweight, they're often really easy to set up and use because of their good platform integrations. Be careful, the supported functions differ quite significantly, right? So make your research there. What are the required features and which of these components offers the required features? And on the other hand, they can often be extended using custom plugins. So this is pretty cool. So it's kind of a bit of option B here. So if you're missing a feature, then, well, I don't know, write a Go module and just link that into the executable, and then you have the additional features. So my advice would be pick one of these if you're in the Kubernetes world. If you already have a Kubernetes-based container platform, internal developer platform, then this is definitely the safe option to go. Be careful with option B, and option A is like for huge enterprise central deployments. Okay, so now I talked a lot about gateways, and the last 1 minute and 30, I want to talk about something called the agentic layer. Now, having all these gateways is not enough if you think about really production-ready, scalable, secure, yada operation of agentic workloads on your Kubernetes cluster. And that's why some colleagues and I, we've been working on this open source project called Agentic Layer. And what we tried to implement is the conceptual idea of an agentic control plane, okay? And these are the components of agentic control plane. So these are the gateways I talked about before, and you need some additional stuff. You need to make sure of the observability. You need some components that handle compliance and auditing. So in terms of governance, you need some form of runtime to operate your agents. Quality assurance is really important, and the guardrails. So what we implemented is kind of a Kubernetes native reference, but it's all open source, okay? Implementation of something called the control plane, which is vendor neutral, which is pretty modular, which has testability inbuilt as a cross-cutting concern, and it's also open source. So if you want to put things into production, then it probably would look something like that. You have your agent gateway, that's the ingress. You have the agent runtime operator that takes care of all the deployment and all the correct configuration and wiring of your agents. Framework independent. For the egress stuff, you have AI gateway and tool gateway. And then you have some cross-cutting concerns, which we think are mandatory. You need observability, basically what we said is OpenTelemetry is the standard. Just use any OpenTelemetry implementation out there. You need some guardrails. So what we think is guardrails, content filters, PII redaction. This can pretty much be solved with open policy agents and Rego as a policy language. We have TestBench. TestBench is mainly based on a component called TestCube. Maybe you know, some of you know that. It's also a pretty cool test framework in the Kubernetes ecosystem, and it supports different AI-specific test frameworks like Ragas or PromptFoo, depending on which kind of test you want to run. And I already, and then here, compliance and audit is pretty much also connected to the observability stuff. Okay, that's pretty much it. A bit over time, but thanks for joining. I guess we don't have time for questions. Next speaker's already here. Get in contact. This is the LinkedIn QR code, and then or meet me afterwards. Thanks.